In this video, we're going to look at topic 5, example 1, where we solve inequalities. We're asked to solve an inequality and graph the solution. To solve an inequality, you're going to treat it as if it was an equation. All right, you won't do anything that much differently. Just pretend it's an equation. There are a couple exceptions and things you have to look out for, but treat it as if it was an equation. So the first thing we want to do here is distribute this negative 4. So I would wind up with negative 12x. Negative 4 times negative 1 is a positive 4, plus 6x is greater than or equal to 16. Right. Next, I would look to combine any like terms. In this case, I have negative 12x and a positive 6x. So when those are combined or added together, I would have negative 6x. Plus 4 comes down, greater than or equal to 16. Now that I've cleaned up that left side, I've gotten rid of the parentheses and I've combined like terms, I can start undoing operations. So I will subtract 4 to undo that plus 4. Get negative 6x is greater than or equal to 12. And now I want to divide by negative 6, because I have negative 6 times x. So to undo that multiplication, I'm going to divide. So I get x, and 12 divided by negative 6 is negative 2. Now what I do need to look out for is I divided by a negative here. So I was undoing operations and there was division of a negative number, or division by a negative number. So when that happens, a unique thing happens with inequalities that we don't have to worry about with equations. You're going to take that inequality sign, and the inequality sign is going to flip from a greater than less than into a less than equal than. Right, so we're just going to have basically the inequality sign is going to open the other direction. So it goes from greater than to less than, or it could go from less than to greater than. Now, this scenario here, right, this rule, only applies when you're undoing operations. So if you divide or multiply by a negative number, to undo operations. All right, and that's important. Then the inequality sign gets flipped. All right, so keep that in mind. I'll go over an example. You'll see this as it plays out. But if you had something like 10x over negative 5 is greater than 18, doesn't need to work out very nicely. Here, I'm not undoing operations by dividing that negative 5. So I would do 10 divided by negative 5. I would get negative 2x. However, since I'm not undoing anything, my inequality sign would stay the same. Right, so it would not change that. But in my next step, when I divided by this negative 2 here, then since I'm now undoing operations, now the inequality sign would flip. All right, so be careful when you flip the inequality sign. You want to make sure that you are only flipping the inequality sign if you are undoing operations. So if you do the same process of division or multiplication on both the left and right side, you would have to flip that inequality sign. Okay, so keep that in mind. So we've now solved our inequality. We get x is less than or equal to negative 2. And what we want to do next is we want to graph the solution. So we solve this. Now we're looking to graph the solution. Right, and to do that, this negative 2 that you have, I'm going to put that right in the middle of my graph, or close to the middle. Center that up a little bit better. So I have negative 2, and then we'll put a couple numbers on each side. So I'd say negative 1, 0, and 1. And maybe I'll go with negative 3, negative 4, and negative 5. 2 or 3 numbers on each side is good. Really, you only need to show 1 number on each side to kind of get the idea and to help yourself along, but a couple numbers will work. So from here, you're going to look to graph this solution, this inequality. The x is less than or equal to negative 2. So at negative 2, we need to decide whether we're going to put an open or a closed circle. Well, we need to ask ourselves, is negative 2 part of the solution? Well, the answer is yes, because we have x is less than and equal to. That equal part, so this underlined here, that equal part tells me that -2 is part of my solution. So I'm going to put in circle, but I'm going to fill it in. It would be a closed circle. And then I want the numbers that are less than -2. Well, those numbers would be on the left side here. So I would shade everything on this left side. And sometimes you want to put this arrow here. There is an arrow there, but we kind of want to put that arrow so that we know that this inequality solution continues to the left. All right, we want all of the numbers going towards -infinity. And that would be my solution. That would be the graph to the solution. What you want to be aware of is, let's say I had something like x is greater than 0. In this case, my solutions are greater than 0, but they're not equal to. There's no equal sign in this case. So if it's just greater than or less than, what you would wind up putting is just an open circle. All right, and then you would shade right in this case, and you would have something that looks like this. But what's important to note is that if there is if there is an equal sign, you need to have a closed circle. If there's no equal sign, in the case of that 0 one there, it would be an open circle. So let's get rid of that so we don't think that's part of our solution. And there we go. Two things to be very aware of are when you're dividing or multiplying by a negative number, make sure you're undoing two undo operations, make sure you're flipping the inequality sign, and make sure you're careful about whether or not you would have an open or closed circle.